Welcome to the video series of Power Electronics and Drives course, unit number 4. The introduction part is the first half of this series, and the second part is your part B, DC drives. Let me see here a thyristor converter fed DC drive, one quadrant operation and two quadrant operation. What we are discussing here, it is a single phase one quadrant drive. For one quadrant drive, it may be one thyristor controlled rectifier or two thyristor two diode controlled rectifier. See here the block diagram of a single phase one quadrant drive. The block green color represents the thyristor symbol, which may be a thyristor controlled converter or a diode uncontrolled rectifier, right? And the left hand side P and N is your single phase AC supply, and the output Vt is your terminal voltage, which is DC in nature, which is given to the armature. The quadrant one quadrant operation is shown in the right hand side, where speed versus torque, speed in terms of omega and torque in terms of t. The quadrant is first quadrant, both speed and torque is positive. You mean forward motoring mode. The circuit diagram for one quadrant may be two diodes and two thyristors. The input supply AC, it is Vs, and the output voltage DC is given to the armature. Here it is an armature voltage controlled method, because the DC supply is a controlled one which is given to the armature in order to vary the speed. Whereas here the field winding is independent, where the supply DC supply is given by with the help of an uncontrolled rectifier if AC supply is available in that area. Right now, the waveform, the input voltage is AC sinusoidal, whereas the output voltage is DC pulsating, V naught output voltage. Now let me discuss this single phase one quadrant drive with the help of a fan motor load, where a regulator comes into picture. If the regulator moves, the thyristor firing angle changes. You mean the thyristor firing angle changes such that the output voltage given to the armature changes, hence the speed of the motor changes. Now let me see that. Here this is the fan motor drive. The left hand side is your voltage controller. Now the voltage controller is in position off, therefore the motor is in off condition. See the fan blade, it is in off. If the motor position is in the low, then the fan motor increases. If it is in medium, it is again further increases, and if it is high, it is further increases. See the operation. It is low, the speed is low, and if it is medium, it is faster, and it is high, it is very faster, right? Now the DC drive circuit. The DC drive circuit consists of three blocks. One is operator controller, which is nothing but the modulator. The driver controller is nothing but the pulse generator circuit or a triggering pulses, which is nothing, and the DC motor is in the right hand side. The driver circuit is your volume controller, right? Now there are two methods of control. One is phase control device, another one is pulse width modulator devices controllers. This is a DC motor, DC shunt motor, which is utilized here for the fan, for controlling the fan. Now let me discuss about the phase control techniques. See here, there are two diodes and two thyristors are there, and the input is the AC supply, which is green in color, and the output is the red in color waveform, which is across your armature. The speed adjustment is shown here, which is a phase controller. Phase control. It has a low, medium, and high positions. low, medium, and high position. A phase control technique is utilized here. Suppose if the phase control technique is medium, then the waveform will be like this. When this is low, then the waveform will be like this. And if it is high, the waveform, output waveform will be like this. Such that if the triggering angle of the thyristor is 10 or 20 degree, the output voltage is very small, the waveform will be very small. And if it is, the triggering angle is 90 degree, the positive of waveform will be a quarter cycle. And if it is 120 degree or 30 degree, then the sorry, if it is some 130 degree, then the waveform will be very small. If it is 130 degree, the waveform will be very small. You mean it is a low voltage. If it is 10 degree, it is high voltage, therefore greater the speed. High voltage, therefore greater the speed. It is a armature voltage control technique. Now let me see the calculation in the next video, how the voltage varies and how the speed varies. Thank you for patient listening.